Hello everyone. Now we will discuss about logarithmic function for class 11th, 12th, 10th maths. Students, a function f which is represent from 0 to infinity to real number. So students, it is the defined that here we have used the domain as 0 to infinity. It means logarithmic function definitely applicable only for positive real numbers. And the function represented by function of x is equal to log of x. It will be the machine log of x. This is, and one more value we will use in place of this place, which is called base, and that is also always positive number and never equal to 1, and in place we will write suppose a. So log function generally represent in the form of log of x base a. F of x is equal to log of x base a. So is it clear here? X definitely greater than 0 always. So domain of this log function always we can find the log only for positive real numbers. But it also but also a is also greater than 0 and a is never equal to 1. This is also the condition. Base, actually this a is called base of log function. So base may base always greater than 0, so it may be less than 1, it may be greater than 1. So there are two cases of logarithmic function. Base is less than 1 or base is greater than 1, then the logarithmic function shows their graph in opposite order in both cases. So students, if we can use some algebra of logarithmic function, if some rules of logarithmic function, so let fx is equal to, suppose we assume that fx is equal to y, then y is equal to log of x base a. This is the logarithmic expression. But a student, it can be converted exponent expression, and it will be converted as a base to the power of this y is equal to, the answer is x. This is the exponent expression. So always remember, for example, anywhere is written that is log of x base a is equal to y, it means we can write a to the power of y is equal to x. So it will be easy for calculation for some rules, for to find the some rules of logarithmic function. For example, so many times we have read about that log of x into y or any base is log of x plus log of y. Actually we have used this concept. So students, if we want to prove it, so our question is prove it. Prove that the log of xy is equal to log of x plus log of y. How it is converted? So students, is prove in this proof of this theorem, this rule, let log of x base a is equal to capital A and log of y base a is equal to capital B. So convert both expression in exponential form. When we convert this is in exponential form, then it will be a to the power of y is equal to x, and similarly this will be a to the power of b is equal to y. So students, now if we, because we want to find the log of x into y, so if we multiply this both equation, then it implies a to the power of a into a to the power of b is equal to x into y. If we multiply this equation 1 and 2, left hand side with right hand side, then it will be formed. So now if we use the theory of indices, a to the power of a into a to the power of b, it means a to the power of a plus b is equal to x into y. So now again reconvert this expression in log form. It means it implies log of xy base a is equal to a plus b. So students, it is proved because a is equal to log of x and b is equal to log of y. So in this way we can prove log of x into y base a is equal to log of x base a plus log of y base b. So this is very important tool. So many times we will use in our so many problems. So students, always remember that log of x into y is equal to log of x on same base plus log of y on same base. So similarly we can prove again the question is prove that the log of x upon y base a is equal to log of x base a minus log of y base a. So students, please try it in your home. This proof. In this again we will use the theory of indices. So now some rule may be converted by this rules, that is, if we want to find the log of x to the power of n base a, so we can find the formula for this also, and it is also very important. So now students, we can write it will be x to the power of n, meaning x into x into x into n time. So now use the method of multiplication of log of multiplication of value. It will be used as we know, we have proved it. It will be log of x base a plus log of x base a plus log of x base a plus n time. So it implies it will be n log of x base a. So now this is our third formula. Okay, log of x power n base a, then power will be automatically come the in front of expression, and we can write this in this way. So this is the third formula for log. So we have read the function. After that, the log of xy is equal to log of x plus log of y, and of log of x upon y is equal to log of x minus log y. You will be prove it, and after that we have proved log of x power n is equal to n log x base a. So now students, some results also we will find. Suppose somewhere we want to write the value of log of 1 base a. This is what, suppose we want to find log of 1 of base a is what. Okay, we will write, suppose log of 1 base a is equal to, let b. So we want to find the value of b, but we know that a is greater than 0, a is not equal to 0. So now if we convert this expression in exponential form, then it will be a to the power of b is equal to 1, and we know that 1 can be written as a to the power of 0, theory of indices. So when we compare a to the power of b with a to the power of 0, it implies b is equal to 0. So it is a very important result that is log of 1 base a is equal to 0. It means log 1 always 0. So is it clear, students? Log of 1 always 0. Similarly, now the fifth formula for log of a value with same base a. This is what? For example, we want to find log of 2 base 2. What is the value of log of 2 base 2, log of 3 base 3, log of... So log of x base x is equal to what? So let this equal to x. Suppose अपन assume कर लिया कि it is x. Then according to conversion of the log function in exponential function, it implies a to the power of x is equal to a, and 1 is always the power of any number, so it implies a to the power of x is equal to a to the power of 1. If we compare these numbers, then it implies x is equal to 1. It means this x is equal to 1. So log of a base a is equal to 1. So this is also a very important formula. For example, log of 5 base 5 is 1. We will use e. E is the exponent. And generally in maths we will use e which value is less than 3 greater than 2, and we will calculate, we have calculated in 11th class. So log e is equal to 1 because e base is understood. Student, it is also important in 12th class, log of function x only represent and the base e is understood. It is height but e is there. Therefore, always log of e is equal to, we will use 1. Log of e is always use 1. So this is the fifth very important formula, students. Please remember it. And now the formula number 6. It is also, that is, if we have a to the power of b, then we can write it directly e to the power of b log a base e. Actually, I am using e because in maths we will use e so many times. E is exponent and base e is not need to express. So this is also a very important formula. Suppose if we want to prove it, how it is possible, okay, then let e to the power of b log a is equal to, suppose I assume that this equal to x, then according to rule of a logarithmic function, we will write b log a is equal to e power x. So students, here we can see the b log a e power, sorry, this is not true. If e power this equal to x, it means x to the power of, it means it's log form, log of x base e is equal to b log a. This is the rule, and b can be converted in this way. So log of x base e is equal to log of a to the power of b. So now when we compare, then it implies a to the power of b is equal to x. So x is equal to a to the power of b, and x is also equal to e to the power of b. So student, this formula we will use so many times, that is a to the power of b is always can be written as e power b log a, and it is important for our so many differentiation question which of functions. Thank you.